Hello everyone, welcome to the video explanation for Brian Passwater's topic 2.6 notes, example 1. Example 1 says selected values from several functions are given in the tables below. Sketch the scatter plot for each table, then determine if a linear, quadratic, or exponential model is most appropriate. So, what we do is we go into each of these charts, we take the points, and we graph them. So for instance, on letter A, we go 0, 11, which is right there. 2, 8.2 would be about right here. Again, it doesn't need to be perfect. We're doing the best we can here. 4, 5. It's an exact point. 6, 2.3 would be about right here. And 8, negative 1. Well, that's the only one that's off the chart, but we can estimate where that would be. That would be right there. Now, looking at that data, it is pretty clear that a linear model would be the most appropriate, as the data is just about a straight line. So we should be using a linear model on letter A. On to letter B, again, we're just going to graph these points. So negative 1, 2. 1.5, 5.5 would be right in the middle of that box. 4, 10.5. 6.5, 5.75 would be about right there. And then 9, 2.25. So there we can see the data increases and then decreases. This would imply that a quadratic model would be the most appropriate as the data increases, then decreases. So we should be able to realize that the best fit for that graph would be our quadratic because it has that shape. On to letter C. Again, we're going to graph these points. So 1, 10, 3, 5.2, 5, 2.4, 7, 1.3, 9, 0.7. Now this data sort of linear, but you can see that the data is, while it is decreasing at an increasing rate, which means that we do have a curve to that, which looks that we are looking at an exponential model here. Okay, the output values are more or less proportional. If you look at the data, it is almost, the outputs are almost times 1/2. Each next output is about half of the previous output, which would imply an exponential model. On to letter D. So we graph these, negative 2, 2, 1, 3, 4, 4.5, 7, 6.75, and 10, 10.25. Be about right there. Looking at this, this one is really difficult to see because it's very condensed. But if you look at the output values, those values are actually, they are exactly proportional. Okay, your x's are equal length input value intervals because it's always increasing by 3 each time. So when we look at this model and we say, oh, well, we have equal length input value intervals, and then we realize that each of the outputs is actually proportional as well. It's us multiplying by 3/2 every single time. So this also is an exponential model. And it kind of shows the danger of making assumptions because that data is pretty darn linear. But again, we have to recognize that proportional model and that output is exponential. It is growing at a proportional rate, 3/2. That does it for example 1. Again, graph the points, determine which model would be the best.